Um, and remember to the assignment from week 14, assignment 1 is mostly pictures of what diffraction looks like and um, uh, refraction. So if you cold and wet over there, oh no. Well, I noticed there's a lot of flowers coming up, and maybe they need it. So, but I like to get out this afternoon around 11, walk around. It looks like it's going to be nice. Thanks, Chloe, Gabby. Thanks, Rachel, Thomas, Kylie. All right. Anybody else? Kendrick, good to see you. Dylan, good to see you. Adriana, good to see you. Madeline as well. So get in there and you get some practice here. We'll get you guys started. All right. 5 minutes. Thank you guys for getting in there. Hey, DeAndre, how are you? Get into that. Look at it for me, would you? All right, who's doing the book? That's what I want to know. Hey, right, Zoom recording. Looks like Chloe and Rachel are pretty close. Pretty close. Gabby not far behind. Thomas. All right, thanks, Leah, for getting in there. So the more you practice, the better those pictures have visualized for you guys. So 24 seconds. All right, somebody threw the blocks up there. And 9 seconds. Chloe moved in, Gabby moved in there. Fishing frenzy. All right, first, second, Rachel third, Gabby second, first. Excellent. Okay, so today what we're going to do is we're going to talk about wave interactions. And remember, we talked about wave interactions yesterday where we had noise canceling earbuds. Okay, so we're going to show you what that's all about, why that works the way it does. Again, remember, the reason you're paying a higher price for those earbuds is because it has extra processing, and it has a little microphone that records the sound, the noise sound, and then it interferes with that sound. So the natural sound and the recording interact with each other so you don't hear it. So it's a good idea if you're wearing those noise canceling earbuds when you're walking down the street, especially if you're walking across the street, that you only wear one. Okay, because you know that car honking, it may be canceling that noise and keeping you from being alerted. All right, so always wear one. Yeah, I know what you're saying, that noise canceling, but again, like I said, take one off so that you can hear traffic noise when you want to, right? Right, when you want to. Never wear them if you're driving. Never wear them in while you're driving. Listen, you know, because you won't hear the outside noise as well. All right, so let's take a look at these. Again, we're talking about the technologies that makes this happen. And again, this is something they discovered, and we've been using it ever since. All right, so you may have seen rain if you've gotten rain today. If you see a puddle, I used to, as a kid, I used to go out into the right by the curb when it rained a lot. For some reason, by the curb, the water was rushing by and make little boats. And that was a lot of fun. I used to like to play in the water. Now, these raindrops here, you can see the pattern. There's 4 of them. They interfere with each other. And you can kind of see it right over here. Right? Turn the pen. You can kind of see it right in here and right here, where the waves are bigger in this place than here. smaller here, okay? Bigger and smaller. So that's what we have wave interference about. Now, again, what we talk about when we do wave interference, right? Noise canceling earbuds, but they also radio antenna. Okay, so if you think about a radio antenna is these big things with the lights on the top, they transmit long radio waves. If I put another one next to it, right, it will also have waves, and they're going to be in sync with each other. That means they're going to match, and they're going to combine and create some constructive and destructive wave patterns. And again, the constructive ones make it so that they can push it out farther, and that's a nice part about it. That stronger wave goes out farther. I would hate to be in a concert where the sound, if they had just two speakers in there, where you were in a dead zone, and then you'd have to move because the dead zone would be the lowest amount of sound. So hopefully they make those concerts so you have the best sound you can. If you are getting too much sound, if you're too close, remember, always protect your ears with some ear phone or maybe some ear plugs. Okay, so here is interference. Wave interference occurs, two more waves overlap. And I'll show you that in a little bit with these PhET online labs. Here is constructive. Constructive means to add, right? Combine. So when you think about constructing something, you're adding to the existing structure. Or here we're doing this, so we have waves that are in phase. And what I mean by waves that are in phase, notice this wave and this wave, the crests are synced with each other. And the troughs are synced as well, right? And they superimpose each other, means that super means on top, pose being on top, they create an amplification. So those two waves create this bigger wave, the bigger troughs and bigger crests. Now, also down here, you'll see the same thing happens when we have a compression wave or a longitudinal wave. Remember, those are the long waves like a slinky, right? And the long waves like a slinky have compressions and rarefactions. And the compressions, when the two waves of sound meet, the compressions get thicker, bigger. The compressions are where they're bundling together, and the rarefactions are they're spreading apart. They're the same thing as, so if I put a wave over this is what this would look like, right? So the compressions and would represent the tallest part of a transverse wave. The rarefactions would be the troughs. Okay, so superimposing, principle of superposition, constructive interference. If a crest of one wave meets a crest of another wave, resulting in the amplitude as a sum. So here's wave 1 and wave 2. Notice they're in sync with each other, right? This one is in sync with this one. And then we add those two together, and this is what it results or equals to: a bigger wave, bigger troughs, bigger crests. The resulting wave is the sum of those amplitudes, right? And destructive interference is when they're out of phase, okay? So when they're out of phase, 180 degrees out of phase, so that means this crest and this trough are made so 180 degrees, so swing over, and then the resulting one is that noise cancellation we were talking about. Noise cancellation, no noise, okay? Crest and troughs meet. So here's one going like this. Here's one going like that. They meet each other. The resulting wave is this zero or destructive or even just softer sound. So makes it really kind of neat to have those. So here's another picture of that, the destructive interference. One wave meets the trough, the crest meets a trough, and they have zero amplitude. In this way, they cancel each other. Just needed to cough there. Okay, so from this diagram, what do you think this is trying to tell us here? So let me just start a poll here. A is constructive. I know, just want to see if you guys are paying attention. Constructive, or B, destructive. So this is kind of what, because you can't see it in time, you know, again, like it's not a, this would be a multiple choice question where you have to see the picture. So what do you think this is? Is this constructive or destructive? What do you think? All right. So here is what's happening. I've got a wave coming this direction right here, and sometime later, this happens. Bigger wave happens, and then the wave passes. What do you think? Constructive or destructive? How about you, Grace? Journey, good morning. Madeline, Renaya, what do you think? A or B? A or B? Can I get any more people in there? I've got Chloe, DeAndre, Rachel, Thomas, Adriana, Gabby, Kendrick, and Kylie. How about if I get Journey, Madison, Chloe Mason, Grace, Dylan, Carmen, or Leah? Come on, guys. Get some votes in there. Tell me what you think this is. We got 4 and 4. Equal parts here. 4 people say yes, it's constructive, and B, people say it's destructive. Okay. So let me go and say that for you guys, most of you guys said it was B, but let's take a look at the question again. Okay. Right. So destructive, these are out of sync, and you get the resultant zero amplitude. Okay. And what we got here, we didn't get zero amplitude, we got a bigger wave, right? So so this was constructive. I know it's hard because of the fact that the you're not seeing in real time. How about this one? All right, start a poll. Is this constructive or destructive? So you got a wave coming from this side and a trough coming from this side. They meet up, and a wave, trough, and a crest come together. You have this line. The resultant line is A plus B is just a flat line, and they pass off. There, you guys are getting it. All right. Thanks for participating. They've got 5 people so far, 6 people, right? So come on, Aaliyah, Carmen, Gabby, Grace, Journey, Madeline, Thomas. Come on, get a vote in there. That's 7 of you. You guys are doing great. 9 out of 16. Anybody else? All right. All right. So, and most of you got this one right. This was the destructive one. So let's take a quick look at these types of waves. Okay. So when we go over to wave interference here, so let's, first of all, if you want to play with this, all right, I'll give you the link here. All right, so let me give you this in the public chat here. If you want to play with this a little bit, your exit quiz looks like this. Okay, so you're going to play around with this and then tell me where the constructive and destructive parts are. So first of all, hit this and you get these waves, right? So typically you got a water wave, right? I got sound, and I have light waves as well. I can do light, can do that. So water waves, sound waves, right? So let's go back to the water. You can see the drip here and the frequency of the drips, how many drips happen. It's faster if I get to the maximum frequency. So a faster number of drips or disturbances. Remember, waves are disturbances. If I want to slow it down, I can. I can't for some reason. So there we go. Slowing the drips here. And the amplitude, I can change the size of the water drip, right? Small water drip, so not many, it's not much amplitude. It kind of looks a little cloudy, but we can kind of leave it in the middle here. So what we can do on this is we can, with two, I'm going to take the gray one and put it over here. I can see the wave happening, right? So here is the white parts are the crests. The dark parts are the troughs, right? So I can do that. I can see the waves, the crests and troughs, right? I can change the frequency, and I can see more waves. They're closer together. So the frequency changes and the waves are closer together, right? Okay. So let's take a look at this next one where we're going to look at wave interference. Okay, so that's what the wave looks like without being interfered with. We're going to look at two water waves now. So I'm going to turn this one on. And I'm going to turn this one on. So they're synced with each other. So they're going down the same, right? Now notice that the waves, they are hitting each other, and the brightness of the wave, let's take a look at the brightness of the wave compared to by itself. Okay, I'm turning this off. Oops, I'm not turning this off. So notice that the brightness goes down. So that means that with the brightness going down, that means that the wave amplitude is less. Okay? Right? So I'm going to put these together here, sync together. Notice that the brightness happens, and then they have these gray bands. So what you're going to be doing for your assignment, right, is you're going to try and find where the destructive waves are and the constructive waves. Okay? So, and there's a range of places here. So you can use this right here. All right, and I'm just going to, okay, so I can look at, let's see if I can get this down to 1. Okay, if I look at just one wave, right, I can see the crest and the trough. They're pretty big. Okay, now if I look over here in the gray band here, or in the dark one, I have almost, there's very little wave there compared to this one. This one has a lot of wave. And this one, let's go back over here. Almost no wave. Okay, so using this, you can decide. And again, what we're going to try and do is we're going to try and write on here, like, what does this part represent? And that won't let me write. Okay, because of this, it won't let me write. So you're going to write constructive or destructive on this particular wave. Now I'm going to use this with, I'm going to change it to sound. And sound does the same thing, has crests and troughs as well. You can kind of see where it is, crests and troughs. The destructive you can see by a line that shows you no movement, okay, or very little movement. That's where the noise canceling is happening. And where you have the highest wave, that's where you have the constructive interference. Okay, so you're going to be doing that in this Nearpod assignment, right? You can test it out for yourself, right? You also get a chance to play with particles. Here's particles, air particles, because the air speakers produce vibrations to move the air, right? And again, you notice that the particles do not go very far. They just kind of bounce and come back. They kind of are like on strings, but they bounce and hit something, and then that collision makes them go back to their original position. So you can see both. Okay. Right. So does that make sense? So here is your assignment for today for exit quiz. This is 10 points. I'll give you this link here. Right. And so watch the video if if it doesn't make sense to you, but you're basically labeling just the constructive places and the destructive places. So you're putting words in there. You're not putting a wave in there, right? So here is the link for the exit quiz. Exit quiz. All right, so I just notified most people that I had like 117 people did not get work week 13 assignment quiz done. So please get to work on that. If you got an email from me, take a look at your emails. That means you did not get it done. Send me a note saying, yes, I will take care of it today. Thanks for the notification. Because if I don't get that, I will be communicating with that home. I really would like you guys to look at your emails, especially on missing assignments. You can also check to see if it's been graded and if it has been graded. So I'm looking at people that had a 0. Okay. So I'm going to pause right now.